In this video, we're going to talk about volume and density. Just a refresher on some of the important volume formulas that we are going to need to know: volume of a prism, pyramid, cylinder, cone, and sphere. And these formulas are all given on the reference sheet on the Regents exam. Just keep in mind that the capital B that you see in the prism formula and the pyramid formula does not refer to base. It stands for the area of the base. And that's very important because it is not just the base, it is the area of whatever the shape of the base is. We'll do some examples so you can see exactly what that means. And we'll be referring back to these volume formulas as we go. Okay, so this first question says, which diagram represents the figure with the greatest volume? So in order to figure out which figure has the greatest volume, I have to actually find the volumes of all of the figures. Now, the first one I see is a cube, and a cube is a type of prism because it has parallel bases. So it is a type of prism. It is a prism with a square base and all square faces. So we have our formula for volume of a prism. It is area of the base times the height. So since the base is a square base, and let me write down the formula, we find the area of a square by doing length times width. But since the length and the width are the same because all sides of a square are equal, the length and the width are going to be the same. So we generally write the area of a square base as side squared times the height, just because the length times the width, since they're both the same, that's the same thing as squaring the side. So we have 4 squared, which is 16, times the height of the cube, which is 4, and that is 64 cubic inches. Remember that we measure volume in cubic units because it's 3 dimensions for 3-dimensional solids. It has length, width, and height. The second solid here is a sphere. So our volume of a sphere formula is 4/3 pi r cubed. And our radius here is 2. The diameter is 4, but the radius is 2. So I'm going to type this into my calculator. 4/3 pi button 2 to the third power. And I got approximately 33.5 cubic inches. Moving on to the third one. The third one is a cylinder. The cylinder volume formula is pi r squared height. So we have pi r squared height. The radius is once again 2 because the radius is half of the diameter, half the whole way across the circular part, times the height, which is 4. Let me put this into my calculator. Pi 2 to the second power times 4. I hit enter and I got that the volume is approximately 50.3 cubic inches. And then finally, I have the cone up last, and the cone formula is 1/3 pi r squared height. And once again, the radius is 2, and the height is 4. Let me type this into my calculator so I can see approximately what the volume is. So I can compare the volumes and I can see which volume is the greatest. I messed up typing in this one, so I'm going to try it again. Pi 2 squared times 4. And I got approximately 16.8 cubic inches. So that tells me that the cube had the greatest volume, but once again, I did have to calculate all of the volumes in order to see that. In the second question we have here, it says determine and state to the nearest tenth the volume of the 3-dimensional solid formed by rotating triangle MHT continuously around H. So we're rotating this right triangle around its side MH. So what we're doing is we're taking this triangle and we're spinning it faster and faster and faster until it becomes a 3D solid around this line. And what will happen when we spin it around and around and around this line is it'll start to look like a cone. And triangles, when you spin them really, really fast and you rotate them really, really fast to make a 3D solid, they do become cones. So we have a cone over here, and we can see that the height is 5 and the radius is 8. So our volume of a cone formula, let's reference back to it, is 1/3 pi r squared height, and our radius is 8, and our height is 5. Let me plug this into my calculator, and it does say to round to the nearest tenth in the question. 1/3 pi 8 squared 5. So that is approximately 335.1 units cubed. It doesn't tell us what the units are, but we should always include our units. They're very, very important, especially as we get later on the video when we start talking about some more difficult volume questions and density, and we start seeing that conversions might be necessary. Okay, take a pause for a second, pause the video and read the question. We are going to be finding the height of a pyramid. So volume of a pyramid formula is 1/3 area of the base times the height. Now, the base of this pyramid is a rectangle, and it has a width of 4.6 and a length of 9 centimeters. I know I put these in the wrong place. It doesn't really matter. So we find the area of the rectangular base by doing length times width. So I'm going to replace area of the base with length times width, which is 4.6 times 9. And we don't know what the height is. That's what we're solving for. But we are given what the volume is. So I'm going to replace that V with what the volume actually is. It is 82.8 cubic centimeters. So now I can use my calculator and solve for H. I'm going to put all of this side into my calculator to simplify what's in front of the H. So 1/3 times 4.6 times 9. And I have that 82.8. The volume is equal to 13.8 times H. Now I'm just going to divide both sides by that 13.8 to get the H by itself. 82.8 divided by 13.8. And I got that the height is 6 centimeters. There we go. Take a minute, pause the video, and read this question. It is a complicated one, so you're going to want to have read it before I start talking about it. Okay, so assuming that you've read the question is asking us how long the generator is going to run once it is filled with gas. If we're talking about filling something up with something to its how much can fit inside something, we're talking about the volume. So we're going to have to find the volume of this tank to figure out how much gas can go into it and figure out how long it can run. So I'm taking a look at the question, and I do have my rectangular prism gas tank. So I'm going to go ahead and find the volume. The volume, the units here are all in centimeters. So my volume is going to be in cubic centimeters, and it is a rectangular prism. So I'm going to do area of the base times the height. Since the base is a rectangle, the area of the base will be length times width. So what I'm really going to have here is length times width times height. That's going to be the area of the base times the height. In my calculator, I'm doing 15 times 20 times 10. And I got that that is 3,000 cubic centimeters. Okay, so now I know how much gas can go inside of this tank. So it's saying here that the generator will run for 2 hours on a liter of gas. But the problem is, I don't know how many liters of gas are going to go inside this tank. I know how many cubic centimeters, that's what my volume is in, are going to go inside this tank, but I don't know how many liters. So I'm not quite sure still how long this generator can run for with 3,000 cubic centimeters worth of gas. So luckily, they have a conversion for us at the bottom so that we can convert our volume from cubic centimeters to liters so that we can figure out how long the generator will run. So it says that 1,000 cubic centimeters is equal to 1 liter. So liter is the bigger unit. So to get from cubic centimeters to liters, I am going to divide by 1,000. And I got that 3 liters of gas can fit inside this generator. So now, if we know that the generator can run for 2 hours on 1 liter of gas, the question is, how many hours can it run on 3 liters of gas? Well, if it runs for 2 hours on 1 liter, then on 3 liters of gas, it's going to run for 6 hours. And there's our answer. Look out for conversions. The units are very important. Moving along over here, Sally and Mary both get ice cream from an ice cream truck. Sally's ice cream is a cylinder, Mary's ice cream is a cone. In part A, we need to figure out who was served more ice cream, Sally or Mary. So basically, we just need to figure out how much ice cream is in each of these ice cream containers. So that is telling us that we need to find the volume, how much can fit in something. So let's find the volume. So the volume of the cylinder container, so here's Sally's cylinder. The volume of a cylinder is pi r squared times height. So here, the radius is halfway across, so it's 2. And the height is 8. I'm going to put that into my calculator, and I'm going to see approximately what that is so that I'll be able to compare them. So pi 2 squared times 8. And I got approximately 100.53 cubic centimeters. Units are important. Both of the volume units here are cubic centimeters. Okay. Now for Mary's. Mary's is a cone. Volume of a cone is 1/3 pi r squared times height. And the radius of Mary's is half the diameter, and half of 7 would be 3.5 centimeters. So the volume would be with a radius of 3.5. And the height here for Mary's is 12.5 centimeters. So I'm going to put this into my calculator, and I'm going to see approximately what this is, so I'll be able to compare that. So 1/3 pi 3.5 squared, 12.5. And that's approximately 160.352 cubic centimeters of ice cream. So it's clear that Mary was served more ice cream. Mary's ice cream holds more volume than Sally's. And it asks in part B, how much more ice cream was served in the larger one? So I'm just going to subtract. I'm going to do Mary's minus Sally's in my calculator. So that 160 number that I just got minus Sally's. And it says round to the nearest cubic centimeter. I got approximately 59.8, so that rounds up to approximately 60 cubic centimeters if we're rounding to the nearest whole number, the nearest cubic centimeter. Here we have another question that might be a little bit hard to understand unless you pause the video and read it first, so please do that. Okay, and this question, we are talking about two pools. We are talking about a rectangular pool and we're talking about a circular pool. So it's asking if both pools are filled 6 inches from the top of the pool, who paid more to fill up the pool? So once again, we're talking about filling up the pool, filling something up with something. So we're talking about volume here. We're going to have to find the volumes of the pool. So let me make a spot for Teresa's pool. That's the rectangular pool. And for Nancy's pool, that's the circular pool. And I do also want to keep in mind the units. The units are all feet. So I want to also keep that in mind. Okay, Teresa's is a rectangular pool. So remember that we can find the volume of anything by taking the area of the base and multiplying by the height. So if it's a rectangular pool, the area of the base, since it's a rectangle, will be length times width. So what we're going to have here is length times width times height. So the length is given to us as 30 feet. The width is given to us as 15 feet, and the height or the depth in this case of the pool is 4 feet. But we're not filling the pool all the way up to the top. We're filling it 6 inches from the top, and 6 inches is half a foot. So we're going to take half a foot off from the depth, which is the same thing as the height in this case of the pool. So instead of using 4 for the depth or the height, we're going to use 3.5. That's taking half a foot or 6 inches off from how much we're filling up the pool. So putting this into my calculator, 30 times 15 times 3.5, and I got 1,575 cubic feet. Okay, now we're on to Nancy's pool. So Nancy's pool is a circular pool. So the area of a circle, since area of the base times the height gives us the volume of any 3D solid. So since it's a circle base, area of a circle is pi r squared times the height or the depth in this case of the pool, which ends up being the same thing as the cylinder formula. So let's plug in what we know here. It has a diameter of 24 feet. Half of that would be 12, so that's the radius. And once again, we're filling the pool not all the way to the top, 6 inches from the top, which once again is half a foot. So instead of using 4, we're going to take half a foot off of that, and we're going to use 3.5. Let me put this into my calculator and see what this is. I have pi 12 squared times 3.5, and that is approximately 1,583. I'm going to leave a few decimal places, 0.363 cubic feet. Okay, so we need to figure out, now we have the volumes, but we still need to figure out who paid more to fill the pool. So it says that Teresa paid $3.95 per 100 gallons of water. And Nancy paid $200 per 6,000 gallons of water. So that's talking about gallons of water. But we don't know how many gallons of water are making up this pool because we have our volumes in cubic feet. So we actually have to convert our volumes from cubic feet to gallons so that we know how many gallons can fill up this pool in the first place. So luckily in the question, they give us the conversion. 1 cubic foot of water is equal to 7.48 gallons. So in order to change from cubic feet to gallons, we're going to multiply by 7.48. So I'm going to do that to each of the pools, to their volumes, to convert from cubic feet to gallons. So I have that this volume is 11,781 gallons. And I have that this volume, let me do that one on my calculator now, is approximately 11,843.553 gallons. Now, the price that they're paying is not for 1 gallon. Teresa's paying $3.95 for 100 gallons, and Nancy's paying $200 for 6,000 gallons. So what I'm going to do now is I'm just going to divide by 100 here, and I'm going to divide by 6,000 here. So let me do that on my calculator. Divide the first one by 100, and I got that number here. And for these so this is how many 100 gallons of water are in the pool. So if I take that and multiply by the cost, I can see how much Teresa paid to fill up her pool. So Teresa paid about $465.35 approximately. Okay, now on to Nancy's pool. Let me divide by 6,000. And when I divided by 6,000, I got about 1.974. So that's how many 6,000 gallons of water are in the pool. So I could just multiply that by the cost to see how much Nancy is actually paying to fill up the pool. And I got approximately $394.79. So Teresa is actually paying more money to fill up her pool, even though initially, from just looking at the numbers here, it might have seemed like maybe Nancy was going to pay more, but Teresa is actually paying more to fill up her pool. And that's all the question was asking, to determine and state who paid more to fill her pool. So the answer would be Teresa paid more to fill up her pool. This is a long video. So the last thing I'm going to talk about in this video is this question over here. We have two cylinders, and it's told that they have that Sue thinks that these cylinders have equal volumes. The question is Sue correct? So if we take a second and just calculate the volumes of each, volume formula of a cylinder is pi r squared times height. The radius here is 5, and the height is 11.5 of the cylinder. Over here, it's the same formula, it's still a cylinder. And the radius is half the diameter, which is 5. And the height, which is the altitude, is still 11.5. So notice that even though these look a little bit different, that this one is a right cylinder and this one is an oblique cylinder, it's slanted, they still are going to have the same volumes because we're still plugging in the same stuff. And the reason for that is due to something called Cavalieri's principle, which I am going to write down. And what Cavalieri's principle says, let me spell that correctly, is that if two solids have the same base area and the same height, they will have the same volumes. So here we can say, yes, Sue is correct, since both cylinders have the same area of the base and the same height, they will have equal volumes due to Cavalieri's principle. And that answers the question. And if you think about it for a second, we find volume by doing area of the base times the height. So if two things, even if they don't look exactly the same, if they have the same area of the base and they have the same height, then they are going to end up having the same volumes.